Gigabit Ethernet. So it has two approaches. One is half duplex and full duplex. So Gigabit Ethernet, the data transmission rate is 1000 megabits per second. So it uses same 48-bit address and same minimum and maximum frame length. We saw that minimum frame length is 512 bits and maximum frame length is 1518 bits. So everything is same here, but it is compatible when compared to fast Ethernet and the standard Ethernet. Here mostly we use full duplex, not a half duplex. So because instead of CSMA CD we are using signal attenuation. So collision is avoided here. Only minimum chances to get collision in full duplex. Half duplex is rarely used because it uses the CSMA CD method, collision detection. Maximum length of network is depending on the minimum frame size in half duplex. So three methods are used in Gigabit Ethernet, that is traditional, carrier extension and frame bursting. Traditional, minimum frame length, as we saw that it is 512 bits and the length of bits, that is 1 by 100 times shorter in the Gigabit Ethernet. Then in standard Ethernet it is 10 Mbps. Okay, we have to calculate slot time. Slot time is equal to this length, minimum frame length, into the length. We saw that length of bit is 1 by 100 times shorter in Gigabit Ethernet. So 1 by 1000 microseconds. So 512 bit into 1 by 1000 microseconds is equal to 0.512 microseconds in traditional. In carrier extension, for longer network, minimum frame length is increased. It allows the length for 100 meters, but we need to extend it from hub to station. For larger distance we need to use. So maximum length is increased 8 times of the length of 200 meter. So that is 1600 meter. Up to 1600 meter we can extend it. Then the another important concept is frame bursting. Frame bursting is used to improve the efficiency. In order to improve the efficiency, we need to send multiple frames. So when the even though the channel is not ideal, that frames are padded. So padding is done for the frames. That is called as frame bursting to avoid collision. So this is the summary of Gigabit Ethernet. So we use fiber optic cables. So for 1000 base SX, that is 2 wire shortwave. Then 1000 base LX. LX also we use same fiber optic cable, but it is long wave. 2 wire is used. Then 1000 base CX. It is shielded twisted pair cable. So 2 wire. Here copper is used. So for 1000 base T we are using category 5 unshielded twisted pair cables. We need only 2 wires for 1000 base ASX, LX and CX. For 1000 base T we need 4 UTP cables. Then the maximum length is 550 meter for base SX. For base LX we need 5000 meters, and for 1000 base CX it needs only 25 meter. 1000 base T, this needs 100 meter as a maximum length. So block encoding is used, and the type of block encoding we used for 1000 base SX, LX and CX. All these three uses 8B by 10B block encoding method. Then line encoding. Line encoding, all these base SX, LX and CX, everything uses NRZ encoding technique, but 1000 base T uses 4D PAM5. Then we are going to see about 10 gigabit Ethernet. The capacity of 10 gigabit Ethernet is, the data transmission rate is 10 Gbps. So it is compatible when compared to fast Ethernet, standard Ethernet and gigabit Ethernet, because it transmits the data in the rate 10 Gbps. This is the highest rate. The other things are same. It uses same 48-bit address and same minimum and maximum frame format. It allows to connect the LAN into metropolitan area network and wide area network. So the other models are not used, other implementations of Ethernet are not used outside the local area network, but it helps to connect to metropolitan area network and wide area network. It makes compatible with frame relay and ATM. Here CSMA CD is not used. So the summary of 10 gigabit implementations, that is, characteristics are the media, that is the cable connection, transmission medium we used is shortwave, that is about to 850 nanometer, and it is multi-mode 10G base L. There we saw that 1000 base SX, 1000 base LX and 1000 base CX and base T. Here we are having three implementations, that is 10G base S, 10G base L and 10G base E. Base S uses 850 nanometer and base L uses 1310 nanometer, and this base E uses 1550 nanometers. Base S is multi-mode and base L is single mode and base E is also single mode. Maximum length allowed is 300 meters for base S and 10 kilometers for base L, and base E uses 40 kilometers because it is extended, so it uses up to 40 kilometers to connect the network. That's all.